Hi everyone, this is Kuralamudhan Ramakrishnan, and today I will be talking about the service function training using OVN in Kubernetes. We will have introduction about Nodus and deep dive into the Nodus and service function training. And then later part, my colleague Todd will be joining and he will be showcasing the demo. So let's jump into the agenda for today's item. So let's have a little bit recap about Kubernetes networking and have a deep dive into Nodus and also we'll discuss about the service function training and how we are utilizing OVN in Nodus. So this slides deck we put together just to have a recap and also for all the audience to understand about Kubernetes networking. So in Kubernetes, the networking is handled through CNI, and by Kubernetes itself, it doesn't have an entity to handle network at the first place. So the CNI is basically stands for Container Networking Interface, and it's a huge community that basically creates and standardize the CNI spec. And the CNI spec is the way how the containers could able to create the interface, and it's the same mechanism how in Kubernetes we use kubelet to interact with CNIs, and the CNI is the one responsible to create the interfaces. And the networking always remains out of scope in Kubernetes, and that's the reason in Kubernetes the CNI do a lot of heavy lifting, right from starting from multi-networking, user space networking, and all the networking abstractions are done through CNI. And the things that are not discussed in Kubernetes is all about the edge networking and how to bring network as an entity in Kubernetes and how could have virtual and provider networking and SDN solutions, of course, service function training. So because of all this thing, right? So how to make network as one of the entity, right? So these are the reasons, right? We created this project Nodus, and the Nodus is a Latin word for a node, as the name suggests. Nodus is convergence or converging point where it converges both the cloud native networking and the NFV networking concepts together. And Nodus is a network controller in Kubernetes. And in Kubernetes world, we use labels starting from the replication controller to the services to the network policies. Why can't we use the Kubernetes labels for networking as well? And Nodus help us to answer the software defined networking in Kubernetes, and it also take care of edge networking, and it supports both containers and the VM network chaining as well. So this is the transformation we see from normal data-centric based public and private cloud to the edge-based solution where the microservices has been decomposed into multiple edge locations, and how you could able to manage the networking solutions in the edge, right? So this is quite different from the way or the legacy way of deploying the microservices in a data-centric approach. Moving towards the edge, the networking became complicated, and managing the networking and make sure that the edge locations are connected to the right provider network. It's also a challenging task to manage. So even if you zoom into the one of the edge locations, right, you could have multiple tenant, right, that able to access the same edge location, and the traffic has to go through the ingress L7 load balancer, then it has to go through the various VNF or CNF applications to reach the internet. So let's discuss about what are the flows available, right? So this is the first flow, right? So the packets from the microservice has to reach the internet, or from a customer has to consume your microservices, then the packet has to go through the external router, then comes to the SD-WAN CNF, then the next generation firewall, then to the load balancer, then to the ingress L7 load balancer, then to the pod. And let's go with another flow. Suppose if you have a corporate network or a private network within that edge location, right? It has to consume some microservices on that edge location. Then it has to go through the provider network, right? And then it has to go through the load balancer. Then it has to hit the L7 load balancer, then the microservice. So like this, right? The same way, if the corporate network physical server wants to reach the internet, it again has to go through the multiple VNF application for the network security and also for the security for the edge location as well. So if you look at this, there are multiple flows involved, and right now these flows required multiple networking. For example, you required default network, provider network, and multiple virtual networking in between. So how you manage all this virtual network, right? That without having an entity in Kubernetes, right? Managing the network by the cloud admin itself will become complicated, and it's not that cost effective. So the solution what we offer is the Nodus will able to manage all the underlying work for you, how to create the provider network, how to create the virtual network, and how to place your workloads, both the VNFs and CNF workloads in between these provider networks, right? So those are the things Nodus will take care of. And Nodus is also make sure that you can manage this network even before the pods are created. So one of the things different from the CNI, right? So CNI is basically invoked during the pod creation and deletion phase, right? So this mostly primarily for the interface creation. The Nodus is mostly for the network creation and managing the networks, bookkeeping the networks, and also deleting those networks. So in Kubernetes, we able to show the network as one of the entity using Nodus as a network controller. So here you can see the multiple networking features, creation and deletion of on maintaining the dynamic virtual network, provider network, and multiple interfaces, and network function chaining and load balancing for those network functions as well. So we able to achieve this one by make sure that there is no changes on the all the network function. For example, the load balancer, next generation firewall, and SD-WAN CNF. There should not be any change for the VNF vendors. If they develop a LSB, if they able to run in the VM the same LSB, they could able to containerize and they could run it in a container. There should not be any specific change of requirements for both VNF and CNF based application, and there is no change in terms of apps configuration as well. There should not be no changes in terms of network function and also for the configuration part. And we able to achieve all these things through the Kubernetes operator framework. And for high performance, we are using SR-IOV VF representator in OVS. And moving forward, we will be working on smart NICs and also exploring the opportunity of OVS, AF XTP, as well as for the packet processing. And why we choose OVN? The one of the thing we fascinated about OVN is we could able to program it very well, and it basically help us to hide all the OVS complexity, and we can manage L2 layer as well. And the one of the thing is that we like to manage one single level IPAM for the entire cluster. So we don't need to manage the IPAM for each node. Right, so that is one of the limitations with CNIs, that you have to manage the IPAM for each node, and the possibility is like kind of endless, right? So you can apply multiple networking concepts starting from the firewall, routing, switching, load balancing, networking policies. You can achieve all these things through OVN. And the OVN is also SmartNIC friendly. So we could able to achieve SmartNIC profiling using Kubernetes as well. And this is the architecture about Nodus. So what we did is like we containerized the OVN. So in OVN control plane, you can see the OVN database and OVN northbound and southbound entities are containerized and they are exposed as a microservices. On minion node, you can see, or in worker nodes, you can see OVS database and OVS switches are containerized. And there are two entities, for example, the one Nodus NFN operator and Nodus NFS agent. The Nodus NFS operator is the one developed as a multiple Kubernetes operator. So a single operator could able to manage multiple CRD definitions. For each CRD definitions, you will have their corresponding manager, and you will have a pod watcher that basically watch the pod creation and the deletion, and you have a synchronizer. So whenever the user wants to create a virtual network or provide a network, their corresponding manager is invoked, and it basically send the information to OVN control plane, and the OVN control plane send the information to the OVS DB, and the same way the NFS operator also send the information to the minion, so that the minion, where it also act like a CNI server, where it could able to configure or doing the network plumbing work for us. So let's dive into how the traffics look like. So here you can see the red lines are basically showing the external traffic. So when the pod has to ping, for example, ping the or curl external server, it has to go through the Nodus gateway interface, that is Nodus Node 1 interface, and then it do the SNET and exit a physical server, and for the inter traffic it goes through the OVS BR init switch, and for the inter traffic it goes through the GNU tunneling. So let's jump into the service function chaining, right? So as I mentioned before in the architectural diagram, that we want to make the network as an entity in Kubernetes. So how you can achieve that, right? By using Kubernetes operator framework. In Kubernetes operator framework, you can create your own custom resource definition, and you can able to create those entities in Kubernetes. So the same way we are using Nodus. So the Nodus, you have a CRD definition for virtual network, provider network, and this is one of the examples we want to showcase is the service function chaining. So the interesting part here is that the thing we want to highlight here is the network labels, right? So you can see the network label. This is a label for the network, and the label for the workload or the VNFs. For in this case is a smart load balancer. Then another, then the virtual network label, then again the next generation firewall application label, and then the network label, then the SD-WAN label. So what we are doing here is that just by simplifying the network abstraction as a label, right? You could able to bring up the pods, and you can attach the pod with those interfaces dynamically on the fly, and Nodus will take care of make sure that the traffic, the packets able to flow from LSB to the next generation firewall to the SD-WAN. And the next diagram will be detailed one. where the Nodus could able to work along with other CNIs. All right, in this example, we used Calico as a primary network and Nodus as a secondary network. But look, so the Nodus is it's a network controller and it's also the CNI. It can work as both the primary and the secondary network. But what we want to showcase is that if you want to have high flexibility in your cluster, Nodus could able to work with any CNIs, and you can achieve the service function chaining. So in this case, you can see the inter-traffic is going through the pod 1 to pod n through the load through the service function chaining flow, that is from LSB to next generation firewall and to SD-WAN. And also, if you want to send the traffic right between two physical servers or through reach the internet, right? So for example, if the packet generator has to pull a patch or send the traffic to the external server, right, through the internet, right? That is also possible here, right? So here you can see there are two different flows that happens that is running through the same network functions at the same time. So this is some kind of advanced service function chaining we could able to achieve in Nodus. And those, what are the things we right now doing is we able to upstream Nodus as a primary network in Kubespray, and we tested it with multiple VNFs and CNF application, and we right now working on network policy based on OVN ACLs. And if you want to try out, here are the multiple links for you. And the work in progress is we are working on SR-IOV VF representator and also creating the Kube proxy based upon the OVN load balancer, and how to expose the service function chaining using multiple network functions using MAC based load balancing. And also we are currently working on IPv6 support as well for Nodus. So in the next session, we will have Todd. Todd will be showcasing a short demo for Nodus. Thank you.
Hello everyone, my name is Todd Malsbary. I'm going to be showing a brief demonstration of service function chaining with Nodus. So diagram in the upper half of the screen shows the network I've been demonstrating. Terminal on the left hand side is to the TM1 server on the left. Terminal on the right hand side is to the Kubernetes cluster in the middle, which is the lighter colored boxes. So the first thing I'm going to show is I'm going to show a ping and a curl from TM1 trying to reach out to the internet. Now the service function chain has not been installed yet, so you don't expect this to work yet. So you see the ping failed, and the curl is also going to fail. Okay, so we see it, and then the routing's been set up yet. So next, what we're going to do is install that green arrow, the service function chain. So first, I'm going to take a quick look at it. Right about in the middle of the screen, you see the network chain there, and all those components, app equals SLB, etc. Those are all, the boxes you see in the upper diagram. And we've also got the provider networks on the left and the right-hand side. So hopefully that corresponds kind of roughly one-to-one to what you're expecting. So we're just going to kubectl apply that. That'll instantiate all the pieces we need there, and then we'll try the ping and curl test again. Back from the TM1 node on the left. Okay, and that's working, so the chain is in place. Now there's one more thing I want to show off, which is the SD-WAN CNF. So we've got that in place, so let's exercise some of that functionality. So what I'm going to show here is we're going to put some rules into that SD-WAN CNF to block ICMP traffic. So without going too much detail, what the details of CNF, it's not that complicated, but what we're going to do is we're going to set up a couple firewall zones, one for a dynamic network, one for the right provider network. See that right here, firewall zone, dynamic network 2, another one for right provider network. And then we'll set up a rule to block ICMP traffic from going from dynamic network intended for the right provider network. And we'll look at the rule to reject. So right at the bottom there, the spec to reject ICMP traffic. Okay, so similar thing, I'll apply those. Now there's some extra noise in here for me, just that I double check that everything got set up properly on the CNF. You can ignore that, but just applying the zones and applying the rules. And then I'm going to do the ping and the curl test again in just a second. And here we go. Okay, and so the ping is failing. So the service functioning is in action, and the CNF is also doing its function, and there we go, and curl is working. And that is a very brief demo. Thank you. Hope you enjoyed that.
I want to thank our speakers, Kuralamudhan and Todd, for that lovely talk. And I think that we have both of them available to answer questions. I don't see any questions yet, but would the two of you like to hop on and talk? You can turn on your video and your audio.
Hi, can you guys hear me? This is Kural.
I can hear you, yes.
Yeah, okay, cool. Yeah, sorry about that. I have some issue with my video actually, so I
That's fine.
Yeah. So we started this project Nodus 1 year before, based upon OVN, and then we start working what are the future in OVN, and then we start working on service function chaining. So we have seen there was multiple patches for service function chaining on OVN, and we able to bring up some kind of a wrapper layer on the top of it. But we are willing to work extensively with OVN communities and also with OVS to work on users plane networking as well in upcoming days.
Todd, do you want to add anything?
Yeah, I've just been working with crawl. I mean, most of my work is on the Kubernetes side, so a little dabbling with this stuff here. Yeah, nothing major to add to what Carl's already said.
Great.
Thanks for having me.
Well, thanks for being here and being part of the presentation. So I see that we now have one question from Flavio Fernandez, who says, in the demo, I see a bunch of IP tables rules. Is your plan to use native OVN ACLs?
Yeah, so right now we are working on the future actually. So right now it's using IP tables, but moving forward, right, everything will be OVN ACLs. Yeah.
That's great to know. Let's see. I think that's the only question that we've got. If another one pops up in the next few seconds, then we'll definitely go through that. But otherwise, it's time to move on to the next talk. And